Okay, we'll look at some arithmetic sum problems here. We have two sum formulas that were proved in the previous video. Number of terms, first term, last term. Number of terms, first term, number of terms, common difference. Here's our general term of an arithmetic sequence. The nth term is equal to the first term plus the number of terms minus 1 times the common difference. And the common difference is known as the difference of two consecutive terms. Let's find the sum of the following sequence. In order to use the easier of the two formulas, you need the first, the last, and the number of terms. Well, we have the first, we have the last. We just need to know how many terms there are. So neither one of these formulas will really give us the number of terms without some additional information. This formula here will give us the number of terms. So I'm just going to use this one here. So the last term is 38. The first term is 2. The number of terms is what I'm solving for. And the common difference is clearly 2. So we get 38 equals 2 plus 2n minus 2. 38 equals 2n. 38 divided by 2 is 19. So we want to find the sum of the first 19 terms, which is 19 divided by 2 times the first term, which is 2, plus the last term, which is 38. So S sub 19 is 19 divided by 2. 2 and 38 is 40, which is 19, these two cancel, gives me 20. I did that in my head without saying it. 20 times 19 is 380. Next one is a word problem where we have 25 seats in the first row, 30 rows in all. So the A sub 1 is 25, N is 30. Each row has one additional seat, so there's our common difference. So we can determine the sum of all 30 rows by using the longer formula, which is 30. I'm going to erase that. 30 divided by 2. 2 times the first, there are 25 seats in the first row, plus 30 minus 1 times the common difference, there's one additional seat, times 1. So this is S sub 30 is equal to 15. 2 times 25 is 50 plus 29. S sub 30 is equal to 15 times 79, which I don't really know what that is. So 15 times 79 is 1185. My apologies. We want to find the sum of the integers from 38 to 94. You would think that the number of terms from 38 to 94, so 94 minus 38, I believe that's 56. Yep, let's just check that. It's 56. You would think that there would be 56 terms. Ironically, there's not. There's 57 terms. And let's look at why that is. Well, if we use the general term of an arithmetic sequence, we can do 94 equals 38 plus n minus 1 times the common difference, which is 1. 94 equals 38 plus n minus 1. 94, 37 plus n. If I do 94 minus 37, I'll get 57. The reason that it is when you actually subtract 94 from 38, what it does is it counts how many numbers there are from 94 up to but not including 38. So it starts with counting to 39 to 94 when you're doing subtraction. We wanted to include 38 because that's part of our sum. So therefore we want to go from 38 to 94, which is a total of 57 terms. So the sum of 57 terms is equal to 57 divided by 2 plus the first plus the last, which is just the two numbers we're working with. And if we just plug that into a calculator without wasting a lot of time, times 38 plus 94 gives me 3762. Here you want to find the sum of the first 60 positive even integers. So our first even integer is obviously 2, 4, 6, 8, 10. And then I want the 60th one would just be 2 times 60, which would be 120. So we have 60 positive even integers. The first one is 2, the last one is 20. So we can find the sum of the 60 integers doing 60 divided by 2. The first one is 2, the last one is 120. So the sum of the 60 terms is 30 times 60 divided by 2 is 30, 122. So 30 times 122 is 3660. Find the sum of all multiples of 6 that are less than 700. Well, the first multiple is 6, then 6 times 2 is 12, 6 times 3 is 18, 24, and then the last one has to be less than 700. So let's check that. We want to do multiples of 6 that are less than 700. So we first want to check, is 700 divisible by 6? 700 divided by 6 is 116.6 repeating. So therefore, if I just drop this off, I know there'll be 116 multiples that are less than 700. So 6 times 116 is 696. So our last multiple of 6 less than 700 is 696. I know there's not another one between 696 and 700 because there need to be another, because 6 plus 696 is 702, which is bigger than 700. So therefore there are 116 terms. Our last is 696 and our first is 6. So 116 terms equals 116 divided by 2, 6 plus 696. So courtesy of my calculator, 6 plus 696 is 4716. Our next one is a little more involved. We have the sum of the first 10 terms of an arithmetic sequence is 75. So S sub 10 is equal to 75. The 10th term is equal to 3. A sub 10 is equal to 3. The question is, what is the third term? So the sum of the first 10 terms is 75, so I can write that as 75 is equal to 10 divided by 2, the first term plus the last term. So I'm just using the simpler of the two arithmetic sum formulas. The first term I don't know, but I happen to know the 10th term is 3. So I do 75 equals 10 divided by 2 is 5. A sub 1 plus 3. So I get 75 equals, I'm going to distribute the 5, so I get 5 times the first term plus 15. I subtract 15 from both sides, I get 60 equals 5 times A sub 1. I divide by 5 and I get 12. So I know the first term is 12. Next thing I need to know is what is the common difference so I can determine the third term. Well, I know A sub 10 is equal to 3. So using this formula here, I can get A sub 10 is 3. So A sub 10 is 3. The first term is 12. The number of terms is 10. Minus 1 is the formula. There's our common difference. Subtract 12 from both sides. I get negative 9 equals 10 minus 1, which is 9. So D equals negative 1. So our third term will be equal to the first term plus the number of terms minus 1 times D. Plugging in what we know the first term is 12. The number of terms is 3 minus 1. The common difference is negative 1. So I get 12 plus 2 times negative 1, which is 12 minus 2, which is 10. So the third term is 10. Look at that. 10th term is 3. Third term is 10. Interesting. Here we have a sigma notation situation. We're given that k equals 1 is our beginning, so our first term is just by plugging k in there, plugging 1 into k. So that would be 2 times 1 plus 1, which is equal to 3. And we just go from 1 to 12 incrementing by 1. So therefore k equals 1. Our next one would be k equals 2. So that would be 2 times 2 plus 1. 4 plus 1 is 5. The third term would be 2 times 3 plus 1. 2 times 3 is 6 plus 1 is 7. Clearly there's a common difference of 2. Our last term is going to be plugging 12 in. So that would be 2 times 12 plus 1, which is equal to 25. So we have the first term, we have the last term, we have the number of terms. So the sum on 12 terms would be 12 divided by 2, 3 plus 25. So the sum on 12 terms is 6 times 28. And 6 times 28 is equal to 168. Here we have arithmetic progression. The sum of the first term, so a sub 1 sum, and the third term is equals is 12 more than is addition the second. If the fourth term is equal to negative 30, what is the ninth term? So let me write this out as two separate equations. A sub 1 plus a sub 3 equals 12 plus a sub 1. And we have a sub 4 is equal to negative 30. The problem is I have 4 variables and only 2 equations. Bad situation. I would like to make it so there's only 2 variables and 2 equations. Well, I have 2 equations. I just need to reduce this down to only 2 variables. Well, the general term of an arithmetic sequence is a sub n equals a sub 1 n minus 1 times d. Well, the first term is a sub 1. Let's write a sub 3 using this formula here. A sub 3 would just be a sub 1, 3 minus 1 times d. So a sub 3 is equal to a1 plus 2d. Notice that the term number is 3, so the number multiplied by d is 1 less than that. So there's a sub 3. This is not a sub 1, that's a sub 2, my mistake. A sub 2 is therefore, if a sub 3 is a1 plus 2 times d, that means a sub 2 would be a1 plus 1 times d, because it's 1 less than that. And a sub 4 will be a1 plus 1 less than 4, which is 3 times d. So let's sub these values into these 2 equations, and hopefully we'll have 2 equations and 2 unknowns. We already know a sub 1 is a sub 1. A sub 3 is equal to a1 plus 2d. So that's a1 plus 2d equals 12 plus a2, which is a1 plus d. A sub 4 is a1 plus 3d equals negative 30. Now I have 2 unknowns, a1 and d, and 2 equations. Perfect. I'm going to simplify the left-hand side here. I get 2a1 plus 2d equals 12 plus a1 plus d. I'm going to move the a1 and the d over onto this side over here. So I get positive a1 plus d is equal to 12. And now I'm going to match it up with this equation here and do a little systems of equations. Conveniently, the coefficient of both the a's is the same, so I can just subtract these 2 equations, and the a1's will cancel out. So those 2 cancel. D minus 3d is negative 2d. 12 minus a negative 30 is positive 42. Dividing by negative 2, I get d equals negative 21. So I know d is negative 21. I now can figure out what the first term is equal to. Well, I can use this situation right here, just plugging in negative 21 for d. So I get a1 plus 3 times negative 21 equals negative 30. So a1 minus, that's 63, equals negative 30. Add 63 to both sides, I get a1 is 33. So the question is, what is the ninth term? Well, the ninth term is equal to the first term plus n minus 1 times d. So a sub 9 is equal to the first term, which is 33, plus 9 minus 1, which is 8, times d, which is negative 21. So that gives me 33 plus 8 times negative 21, gives me negative 135. Last one to go. The sum of the first n terms of a sequence is given by this, so this is the sum of the terms. what is the fifth term of the sequence? Well, and this one's a little unique. If this is the sum of any terms, and I want to know what the fifth term of the sequence is, the easiest way I find to do this is, well, let's figure out what the fifth term is equal to. Well, the sum of the first 5 terms. Well, that will be 5 times 3 times 5 minus 4, and that is equal to 5 times 15 minus 4, which is equal to okay, so I just paused there for a second. So the sum of the first 5 terms is 55. So 15 minus 4 is 11. 5 times 11 is 55. So if I know the sum of the first 5 terms, I should be able to figure out the fifth term if I also know the sum of the first 4 terms. Sum of the first 4 terms is 4 times 3 times 4 minus 4, which is equal to 4 times 12 minus 4, which is 4 times 8, which is 32. So if the sum of the first 4 terms is 32, the sum of the first 5 terms is 55, well, how much do I need to add to the sum of the 4 terms to get the sum of the fifth terms? So essentially, s sub 5 minus s sub 4 must equal a sub 5. So that's just 55 minus 32, which I believe is equal to 23. So there you go.